How are you? Today we are studying chapter 13. This is lesson 121, talking about the chemical equilibrium introduction. This is for grade 12 SABIS, suitable for any A-level chemistry course like AP or A-levels. Before we explain what is the chemical equilibrium, let's speak about two types of chemical actions. Chemical action can be either irreversible chemical reactions. These chemical actions can only go in one direction. So the carbon dioxide will react with the oxygen. What's going to form the carbon dioxide? Let me ask you a question. Is there any chance the carbon dioxide gas goes back and forms the oxygen gas and the solid carbon? No, there is no chance. So this means that the reaction goes only in one direction. That's from the left to right. We call this direction the forward reaction. Some other directions are a little bit different. This is the famous reaction between hydrogen and nitrogen to form ammonia. The hydrogen and nitrogen are my reactants, and the ammonia is my product. After the hydrogen and the nitrogen react to form the ammonia, there is something strange might happen. The ammonia is going to break down back into the hydrogen and nitrogen. So after the ammonia is formed, it will go and form the nitrogen and hydrogen again. If I wrote the reaction in this way, so I'm speaking about ammonia become my reactant now, and the hydrogen and nitrogen became my products. So the reaction is reversed. So this is what we call the backward reaction. This is down here is my backward reaction. So this means the reaction can go in two directions. It's a reversible reaction. It can go in the forward direction, as in the same time it can also go in the backward direction. And both of them happen at the same time. We call this reversible reactions. Take care. This is not equilibrium. Most people think that reversible reactions are equilibrium reactions automatically. The equilibrium is just a status of 1-3 states that might happen. The equilibrium is just one of 3 cases that might be happening. The first case is if the forward reaction and the backward reaction are happening but at two different rates. The speed or the rate of the forward reaction going from left to right is faster than the speed or the rate of the reaction which is going backward. So the rate at which ammonia is formed from nitrogen and hydrogen is much faster than the rate at which the ammonia is going to break down back and form the hydrogen and nitrogen. This leads to accumulation of ammonia over time. Why is that? The concentration of ammonia starts to increase by time because its production is much faster than the production of nitrogen and hydrogen. And the concentration of nitrogen and hydrogen is going to decrease by time because its rate of production is slower than the rate of production of ammonia. This is the first case. So the rate of forward is much more than the rate of the backward direction. The second case is the opposite. Sometimes the rate of the backward direction is much more faster than the forward one. This means that the rate of production of nitrogen and hydrogen from ammonia, this is the backward reaction, is faster than the rate at which the ammonia is formed. This causes the concentration of nitrogen and hydrogen to pile up by time and increase, while the concentration of ammonia is going to slowly decrease. This is because the rate of the backward direction here is much faster than the rate of the forward direction. The third case that happens is when the two rates are equal. This is when the forward direction rate and backward direction rate is equal. So if the forward rate is equal to the backward rate, then at this time we are going to call this reaction equilibrium. So the third case is when the rate of the forward reaction is equal to the rate of the backward reaction. It's not like 1 where the forward was faster and 2 where the backward was faster, Now they are both equal. And when they are equal, this is the only case that we call it equilibrium, and we draw these arrows in reversible reactions if it is in equilibrium or no. But we say that the rate is faster only, again, we draw these arrows if there is reversible reactions. It doesn't mean equilibrium. Only there is equilibrium when the rate of the forward is equal to the rate of the backward. So we said that when the rate of the forward is more than the rate of the backward, the concentration of the products pile up and increase while concentration of reactants decrease. When the backward is faster than the forward, the rate of the backward more than the forward, the concentration of the reactants increased and the products decreased. When the rate of the forward is equal to the rate of the backward, the concentration becomes stable. The concentrations of reactants and the concentration of products, both of them become constant. There is no change. Why? Because there is no more direction faster than the other. So concentration of reactants and products are constant when this happens at equilibrium.